Hello everyone. In the last session, we discussed about what is inductance, what is the unit for inductance, the principle behind the inductance, what is self-inductance and mutual inductance. In this session, let us further continue with the same topic and let's begin with an inductor. So what exactly is this inductor? The physical body or a coil of copper wire wound on a core of some suitable material is called as an inductor. And so a copper wire, in the last session itself I told you, if you are having a length of wire and if that wire is wound on a certain core like this, then this itself will be called as a coil of copper wire. Here they have talked about a coil of copper wire. They have taken a copper wire and they have wound into like this, and this itself will be called as a coil. So an inductor, this itself is called as an inductor, this itself will be called as an inductor. An inductor is a coil of copper wire wound on a core of some suitable material. Core in the sense we are going to take a core upon which the copper wire will be wound like this, and the core can be of different materials. We are going to deal with this in the next topics. So an inductor is nothing but a coil of copper wire wound on some suitable material, and the symbol of this inductor is like this. It's already shown over here. Next, we are going to see what is the energy stored in an inductor. In inductors, due to the change in the current, the work will be done and energy is stored in the magnetic field as magnetic energy. Some amount of work will be done in order to store the energy in the inductor in the form of an magnetic field, and that energy stored can be calculated easily using this formula. E is equal to half Li square. Now let us see the different types of inductors. These inductors are broadly classified into fixed inductors and variable inductors. What is this fixed inductors and variable inductors? Fixed inductors are those inductors where the value of the inductance will be constant. The value of the inductance will not vary. It will be maintained constant. And variable inductors are nothing but those inductors in using which the inductance values can be varied. Let us first discuss about the fixed inductors. Fixed inductors are manufactured for a particular value of inductance only. Their value cannot be changed. Their value will be maintained constant throughout. And depending upon the core what we are using, these fixed inductors are classified into air core inductor, iron core inductor and ferrite core inductor. Let us first see what exactly is this air core inductor. The air core inductor is made of coils of wires wound on an ordinary cardboard. Ordinary cardboard in the sense it is a non-magnetic material. It is not a magnetic material. We are going to take a non-magnetic material. Non-magnetic material, mainly we are going to wound a copper wire, and after that this itself will be called as an air core inductor, where the core is made up of air. Whenever we are going to take a non-magnetic material, the core will be considered as an air core inductor. Since the cardboard does not have any magnetic property, air is considered as the core. Even if coils are wound on non-magnetic materials like ceramic rod or plastic material, they are called as air core coils. If I am going to take a non-magnetic material upon which I am going to wound a coil, wound a wire of copper to make a coil, then that types of inductors will be called as air core inductors. If you are going to look into the uses, the solenoid and the universal winding air core inductors are widely used in communication purpose. So communication purpose in the sense we are going to use these inductors in order to change the frequencies of the signals what we are capturing, that is in the communication purpose. They are used at frequencies up to 2 megahertz RF in the sense radio frequency in radio and television equipments, used as RF chokes, RF transformers and IF transformers. RF chokes ಅಂತ ಹೇಳಿದ್ರೆ radio frequency chokes, RF transformer radio frequency transformers and IF transformer, it is intermediate frequency transformers. This we are going to deal in the second PUC classes. Coming to the next type of inductor, that is iron core inductor. Here the name itself is specifying. We are going to take an iron core. Iron core can be a solid type or a laminated type. laminated type in the sense we are going to take thin sheets of iron. Upon then we are going to place a number of thin sheets to form a thick core. So the iron core inductor is made up of coil of wire wound over a solid or laminated iron core. This core is laminated to avoid eddy current losses. Laminated in the sense, I already told you we are going to take thin sheets of iron core, and every thin sheets of iron core will be laminated with each other in order to avoid the eddy current losses. There will be losses like hysteresis losses and eddy current losses in the transformer. So in order to avoid such losses, we are going to take these laminated iron cores. So this core is laminated to avoid the eddy current losses. A laminated iron core is made up of thin laminations pressed together but insulated from each other. I already told you we are going to take thin sheets of iron material, and every iron sheets will be laminated. Coming to the uses of this iron core inductor, they are suitable for audio frequency applications. EF stands for audio frequency applications, and they are used in radio as well as TV receivers and transmitters. Radio receivers and TV receivers, in the sense, in order to tune the stations from one channel to another channel, we have to change the frequencies. And in order to change the frequencies, we need a separate device, or we need a separate component which helps in tuning the frequencies. And one of the major applications of this inductor is for tuning purpose. And for tuning, we are going to use these inductors in radio as well as TV receivers and transmitters. So these are some of the applications of iron core inductors. Next, let us see into next type of inductor, that is ferrite core inductor. So what is this ferrite core inductor? Ferrite core inductor is made up of coils of wire wound on a solid core of highly ferromagnetic substance called ferrite. Ferrite is a solid magnetic material having high permeability, consisting of fine particles of iron, cobalt, or nickel embedded in an insulator binder. So in the previous type of inductor, we saw iron core inductor, where the inductor was mainly made up of only iron. But here we are going to take an alloy which is made up of iron, cobalt, and nickel, which are mixed together to form a new compound, what is called as ferrite. So here we are going to take ferrite, upon which here we are going to take a ferrite core, upon which a coil of copper, I mean a wire of copper, will be wound to form a coil. So depending upon which material we are going to use, accordingly we are going to classify these inductors as air core inductor, iron core inductors, or ferrite core inductors. Coming to the uses of these ferrite core inductors, they are used at higher frequency range of radio interference suppression, used as filter chokes, used for color TV, raster generation, etc. So used as filter chokes in the sense, filters in the sense will be having a number of signals. Out of these number of signals, we are required to capture, or we are required to tune only a certain range of frequencies. And even in such filtering out, or even in such selection purpose, we are going to use these inductors, where the desired frequencies will be captured, eliminating the undesired frequency signals. So these are the different types of fixed types of inductors. Variable types of inductors ಅಂತ ಹೇಳಿದ್ರೆ, we can easily vary the inductance values for a specified range from 0 to a certain range, as we have already seen in resistors as well as capacitors. Now let us see the combination of inductors. In resistors as well as capacitors, we have already seen what will be the effective capacitance of resistors when they are connected in series or when they are connected in parallel. Similarly, in capacitors also, their capacitance value will be varying when they are connected in series and when they are connected in parallel. Coming to these inductors, even these inductors can be connected in series as well as in parallel. There is no derivation for this. We are directly having the formula what will be the effective value of the inductance when they are connected in series and when they are connected in parallel. Whenever the inductors are connected in series, inductors connected in series ಅಂತ ಹೇಳಿದ್ರೆ when one end of the inductor is connected to only one end of the other inductor, then we are going to call that these two inductors or these inductors are connected in series. And the formula to calculate the total inductance when they are connected in series is this: ls is equal to l1 plus l2 plus l3 plus so on up to ls. The effective inductance of an inductor in series is equal to sum of individual inductances in each coil. Each coil will be having a separate inductances. So whenever these inductors are connected in series, we are just going to add the inductance values of each individual inductors. Okay. So this is the formula to calculate the total inductance when they are connected in series. Inductors connected in parallel. Similarly, like inductors are connected in series tarane, inductors can also be connected in parallel. That is, if the inductors, if I'm having inductors like this, then if the ends of the inductors are connected like this, then we are going to tell that these inductors are connected in parallel. End-to-end connection of the inductors can be called as inductors connected in parallel. And the effective value or the equivalent inductance value when the inductors are connected in parallel formula is 1 by L P stands for parallel is equal to 1 by L1 plus 1 by L2 plus 1 by L3 so on up to 1 by Ln. ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಇಂಡಕ್ಟರ್ಸ್ ಬೇಕಾದ್ರೂ ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಿರ್ಬೋದು. ದಟ್ ಇಸ್ ದ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ದ ಎಫೆಕ್ಟಿವ್ ಇಂಡಕ್ಟೆನ್ಸಸ್ is equal to sum of reciprocal of the inductive individual inductances. If I am having only two inductors connected in parallel, then we are having a direct formula Lp is equal to L1 L2 divided by L1 plus L2. This is a direct formula. ಹೇಗೆ ಹೇಳಿದ್ರೆ 1 by Lp is equal to 1 by L1 plus 1 by L2 ಅಂತ ಆಗುತ್ತೆ. If I am going to take the LCM, L1 L2 will be the LCM that will be in the denominator. In the numerator, I'll be getting L1 plus L2. But this is 1 by Lp. But we need Lp. So we are just going to take the reciprocal of that. So Lp is equal to L1 L2 divided by L1 plus L2. This is the total or the effective inductance value or the equivalent inductance value when the inductors are connected in parallel. Next topic is choke. So what exactly is this choke? This inductor what we are talking about is also called as choke. It is functionally named as choke. The functional name of an inductor is often called as a choke. A choke in general is a coil of insulated wire wound on a magnetic core. We have already seen the different types of inductors. Depending upon which core I'm using, accordingly we are going to classify these inductors as air core inductors, iron core inductors and ferrite core inductors. So if the core is made up of magnetic material and if the wire is wound on that magnetic core, then we are going to call that as a choke. Used as an inductor to block higher frequency alternating current in an electrical circuit. So choke is the functional name of an inductor. So these inductors can also be called as a choke. It is made up of number of turns of thin wire wound on a laminated iron core. I have already told you what exactly is the meaning of laminated iron core. We are going to take thin sheets of iron. Then every thin sheets of iron will be laminated with each other to form a thick iron core. That is laminated iron core. This is sealed in a metal case. The wire is used of copper or aluminum and insulated with an enamel coating. So the wire what we are going to wound on a core will also be laminated with each other. I'm wounding the wire with a specific distance, but when we are going to talk about a transformer or a choke, every wire will be touching with each other. So in order to avoid the short circuit, what we are going to do is each and every wire itself will be insulated with an enamel coating. So the functional name of this inductor is nothing but a choke. And the uses of these choke is used in tube light sets. Tube light sets ಅಂತ ಹೇಳಿದಾಗ, if I am going to take this as consider this as the base of the tube light, fluorescent lamps ಅಂತ ಮುಂಚೆ ಏನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, these days we are using LED bulbs, CFL bulbs ಅಂತ ಆಮೇಲೆ ಬಂತು, ಅದಾದ್ಮೇಲೆ LED bulbs ಅಂತ ಬಂತು. But if we are going to take a tube light set, we'll be having one cylindrical type and the other one which will be box type, and that box type itself will be called as a choke. It is used in tube light sets. It is used as filter chokes in radio as well as TV receivers and also in transmitters for creating voltage surges in fluorescent lamp sets. So if you are going to see the fluorescent lamps, initially some amount of surge will be found, and that is generated or that is created using these chokes, and in RF tuning circuits, etc. These are some of the uses of the chokes. We are going to talk about the relays. Relay is nothing but a simple switch which is operated both electrically and mechanically. These are usually found near the transformers, like transmission lines ಎಲ್ಲಿದೆ ಆ transmission lines ಕಡೆ ಅಥವಾ transformers ಕಡೆ we are going to see these relays, and they can be operated both electrically as well as mechanically. Relay consists of an electromagnet and also a set of contacts. Set of contacts ಅಂತ ಹೇಳಿದಾಗ those contacts will be usually named as normally open and normally closed. NO and NC ಅಂತ ಕರಿತೀವಿ. The switching mechanism is carried with the help of an electromagnet. The circuit diagram is as shown in the figure. Here we'll be having SPDT relay. SPDT ಅಂತ ಹೇಳಿದ್ರೆ single pole double throw relay. Single pole double throw ಅಂತ ಹೇಳಿದ್ರೆ ಒಂದೇ ಒಂದು ಪೋಲ್ ಇರುತ್ತೆ, ಒಂದೇ ಒಂದು pole ಇರುತ್ತೆ. Either I can bend towards this direction or towards this direction. So single pole double throw ಅಂತ ಕರಿತೀವಿ. So the circuit diagram is as shown in the figure, which uses SPDT relay circuit that energizes the green light bulb only when the push button switch is pressed, and energizes the red light bulb when the push button is released. When the push button is released ಅಂತ ಹೇಳಿದಾಗ, here this itself is a push button. Here if according to this diagram, the push button is in the normally open state. Normally open state anta ಹೇಳಿದಾಗ, here I am having a battery. With the help of a battery, the supply will be given to these bulbs. So in this condition, in the normally open condition, the red light will be glowing. The red light will be glowing ಅಂತ ಹೇಳಿದ್ರೆ, this SPDT relay is touching this horizontal line, ಆಗಿರೋದ್ರಿಂದ through the battery the circuit will be completed to the red light bulb. So the red light bulb will be on when the push button is released. As soon as the push button is switched, or as soon as the push button is pressed, then ಇದು ಈ push button ನ ಇಲ್ಲಿ press ಮಾಡಿದ್ದು ಅಂತ ಹೇಳಿದಾಗ, the circuit will be energized. The circuit will be energized ಅಂತ ಹೇಳಿದ್ರೆ, here the circuit will be completed. So circuit will be completed ಅಂತ ಹೇಳಿದಾಗ, this SPDT relay gets activated. Then the arrow mark which is pointing towards the upward direction, that gets energized. So ಈ ಥರ arrow mark ಏನಿದೆ, that gets energized and that will be touching the line, whereas red button ಏನಿತ್ತು, red button ಇಲ್ಲಿ ಮೇಲೆ ಇಲ್ಲಿ SPDT relay ಮೇಲೆ ಇನ್ನೊಂದು arrow mark ಏನಿತ್ತು which was pointing downwards, that will be released. Now this circuit will be completed. I mean to say, ಇಲ್ಲಿ ಬ್ಯಾಟ್ರಿಯಿಂದ ಇಲ್ಲೊಂದು ಗ್ರೀನ್ ಬಲ್ಬ್, ಅದಾದಮೇಲೆ ಈ ಥರ ನನಗೆ ಸರ್ಕ್ಯೂಟ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ದಿಸ್ ವಿಲ್ ಬಿ ಟಚಿಂಗ್ ದ ಲೈನ್. ದಿಸ್ ಇಸ್ ಅ ಬ್ಯಾಟ್ರಿ. ಸೊ ಈ ಥರ ಟಚ್ ಆಯಿತು ಅಂತ ಹೇಳಿದಾಗ ಗ್ರೀನ್ ಬಲ್ಬ್ ವಿಲ್ ಬಿ ಗ್ಲೋಯಿಂಗ್. ಸೊ ವೆನ್ ದ ಪುಷ್ ಬಟನ್ ಈಸ್ pressed, then green light will glow. When the push button is released, a red bulb will glow. And that will be operated completely with the help of an electromagnet. Then where is an electromagnet? Here this SPDT relay itself is an electromagnet, and that electromagnet will completely be depending upon this push button. So the energizing of these coils will be done with the help of this push button. As soon as these coils is energized, then this part will be activated. Coming to the specifications of these relay, the operating voltage, operating current, contact and release time, material of the contact point, operating temperature. Depending upon these specifications, we are going to select different types of relays for different applications. On what voltage, I mean at what temperature we are trying to adapt these relays, accordingly we are going to select different types of relays of which material it is made up of. Coming to the applications, these are used as protective relays to protect electronic equipments against abnormal conditions like overvoltage, overcurrent, short circuit, etc. I've already told you that these relays are usually found near the transformers. So, as soon as we are going to identify a short circuit at any of the point during the rainy season or because of some other reasons, short circuits ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ from that point heavy current starts flowing ಅಂತ ಹೇಳಿದಾಗ to whichever appliances it is connected, to whichever appliances ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ್ಯಾವ ಮನೆಗಳಿಗೆ connections ಹೋಗಿರುತ್ತೋ ಆ appliances will get damaged permanently, will get destroyed. So in order to avoid that, a relay will be placed very much close to a transformer. If any of these short currents, short circuit or over voltage or over current is identified, then these relays gets activated and that will operate these push buttons. As soon as this push buttons is operated, then the circuit will be disconnected. Circuit disconnect ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ we can easily protect the electronic goods whatever it is being connected. And it is also used as transmission relays in communication system, as counters for counting entry into a place. These are also used to count the number of people or to count the number of devices passing through some point. And it is also used as an automatic switching device to operate street lights, garage doors, inverters, bells and buzzers, etc. So these are some of the applications of these relay. Coming to the advantages of these relays, there are a few advantages. Relays require small power, only a few power is required in order to operate these relays. As we have already seen, we need a separate battery in order to operate these relays, and it can turn on or turn off the load from a distance. ಸೊ ಯಾವ್ದಾದ್ರು ಒಂದು ಲೋಡನ್ನು ಆನ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದಾಗ with the help of an electromagnet we can easily turn on or turn off these loads with the help of these relays, and there is no sparking while turning the load on and off. So these are some of the advantages of these relays. So let me conclude this session at this point. In my next session I'll be coming with a new topic. Thank you.